Hello children. Today in this module I am going to explain you some important chemical properties of organic compounds. In carbon compounds we come across with certain reactions, namely addition reaction, substitution reaction, oxidation reaction, dehydration reaction, esterification and saponification for class 10. Right. So initially coming to addition reactions. In addition reactions, unsaturated hydrocarbons like alkenes and alkynes are converted to saturated hydrocarbons, namely alkanes. So industrially these addition reactions are helping us in converting coconut oil into vanaspati ghee. Yes, ethene is present in coconut oil and this ethene is hydrogenated. Like we'll be adding hydrogen gas in the presence of nickel or palladium catalyst, as these nickel, palladium, platinum, all these are transition metals which can hold certain hydrogen gas with them. So they catalyze in adding this reaction, this hydrogen to ethene. Ethene is adding hydrogen molecule and it is converted to ethane. That is the best example for addition reaction. Right? So coconut oil, which is a vegetable oil, is converted into vanaspati ghee. That is the industrial use. Here we go to the chemical reaction. So generally addition reactions can be understood in such a way that alkenes or alkynes, these are adding hydrogen in the presence of nickel or palladium catalyst and they are converted to alkanes. Okay. Now, alkenes are represented with double bond and alkynes are represented with triple bond. These here, they are having like covalent bonds. There are two types of covalent bonds, sigma bonds and pi bonds. And the pi bonds are weaker and the pi bonds are broken by heating. So, when we heat the mixture, the pi bonds are broken and they add hydrogens such that you are getting alkanes. You can see how hydrogens are added. So this can be explained with ethene, like I said, ethene plus hydrogen in the presence of nickel or palladium or platinum, anything, at 250 degrees centigrade. So what is happening? Hydrogen gas is added to ethene such that ethane is obtained. Okay, so here the formula you can write it as C double bond C. There are two hydrogens here. So we also call this as CH2 double bond CH2. Or we can also write it as C2H4. Anyways you can write. This is adding hydrogens. Now you can understand that the bond is broken. These two hydrogens are added such that you will be getting CH3 single bond CH3. Right? This can also be written as CH3 single bond CH3 or you can also write it as C2H6. So in this way ethane is converted to ethene and here I said coconut oil. So this is an unsaturated hydrocarbon. Now it is converted to vanaspati ghee. This is a saturated hydrocarbon. In this way, addition reactions convert alkenes to alkanes. They can convert even alkynes to alkanes. The next property I am going to explain is substitution reactions. Substitution reactions are seen in alkanes where one atom is substituted by another atom. In alkanes, hydrogens are replaced by another atoms like halogens. So here I am going to explain you photolytic halogenation reaction. That is when alkanes are treated with halogens like chlorine or bromine, certain new compounds are formed, substituted halogenated compounds are formed. So substitution reaction is a chemical reaction in which hydrogens are replaced or substituted by halogens, right? So here methane, I am taking methane. The formula of methane is CH4. This methane molecule comes in contact with chlorine in the presence of sunlight. This is a free radical substitution reaction which is done in sunlight, in the presence of sunlight. We also call it as photolytic reactions. Right? Here there are four hydrogens which are connected to carbon. One of the hydrogen is replaced or substituted by chlorine atom such that CH3Cl, and the removed hydrogen and another chlorine atom here comes out in the form of HCl. And the ionic name of this compound is chloromethane. So this is the first step. And a series of substituted compounds are formed, and all the hydrogens which are linked with carbon are replaced by halogens. So again, the same chloromethane again comes in contact with the second mole of chlorine molecule. Again, photolytic substitution takes place, and one more hydrogen is now replaced by one more chlorine atom, such that CH2Cl2, a new compound is formed, and the ionic name is dichloromethane and HCl. And this substitution series goes on until all the hydrogens are substituted by chlorines. So once again, CH2Cl2 plus Cl2 gives rise to CHCl3 plus HCl. So here we call this as trichloromethane. Okay, and there is one more hydrogen which is also replaced by the chlorine. CHCl3 again plus Cl2 gives rise to CCl4 and HCl. This CCl4 is now called as tetra. There are four chlorines, tetrachloromethane. We also call it as carbon tetrachloride, which is one of the important organic solvent. Carbon tetrachloride is a common name, and tetrachloromethane is the ionic name. Here, in this way, methane, as methane is having four hydrogens, to have a series of four substitution reactions wherein four substituted compounds are obtained. So once again I tell you, one hydrogen is replaced by another atom in this substitution reaction. The next chemical property is oxidation. Oxidation of alcohols to carboxylic acids. Alcohols can be oxidized to carboxylic acid by treating them with certain oxidizing agents, namely alkaline KMnO4 or acidified potassium dichromate. What are these? These are the chemical substances which releases nascent oxygens. Atomic oxygens are released, and these atomic oxygens are added to alcohol, and alcohols are converted to acids. Like here, ethanol is converted to ethanoic acid by treating ethanol with alkaline KMnO4 or acidified K2Cr2O7. So addition of oxygen or removal of hydrogens is considered as oxidation. Here we go again. So ethanol is CH3CH2OH. This is ethanol. Ethanol is now treated with alkaline KMnO4. Alkaline in the sense potassium hydroxide. So potassium permanganate crystals are dissolved in potassium hydroxide, or acidified K2Cr2O7. Potassium dichromate crystals are dissolved in dilute sulfuric acid. These two are called oxidizing agents, and they release nascent oxygens. So here hydrogens are removed and oxygen is added, such that CH3COOH, this is ethanoic acid, which is produced. This, I am writing the bonding structure. You can easily understand how the reaction takes place. Here you can see all these are hydrogens. In alcohol, you see a functional group OH. Now what is happening when these are treated with? Right, you can say alkaline in the sense KOH, KMnO4. It can be written like this, or you can also take H2SO4 and K2Cr2O7. These are oxidizing agents. The substances which are producing or which are giving oxygens are called oxidizing agents. Now, as I told you, these are producing certain atomic oxygens. In order to introduce one oxygen into the molecule, two hydrogens are removed. So here this hydrogen and this hydrogen is removed and oxygen is introduced into the molecule such that an alcohol is converted to acid. So here remove it, CH3, and now C, as I told you, remove these two hydrogens and carbon is making a double bond with oxygen. Oxygen is divalent, it needs two bonds to come in contact with the carbon, and OH. So these two hydrogens are removed and one oxygen is introduced. We call this as partial oxidation, conversion of ethanol to ethanoic acid. In the before case, the functional group was OH and now the functional group is COOH, which is carboxylic acid. So in order to convert ethanol to ethanoic acid, ethanol should be treated with alkaline KMnO4 or esterified potassium dichromate solution. Next is dehydration of ethanol. Dehydration agents like concentrated sulfuric acid is added to ethanol such that ethanol is converted to ethene. Ethene is an unsaturated hydrocarbon. Here water molecule is eliminated in this dehydration reaction and ethanol is treated with this concentrated sulfuric acid at 443 Kelvin. The temperature is also very particular. It is giving us an unsaturated hydrocarbon, namely ethene. So once again I tell you, dehydration of ethanol gives us ethene. Ethene is an unsaturated hydrocarbon. Here ethanol. So again I tell you here, ethanol, when it is heated with concentrated H2SO4 at 443 Kelvin. Remember, so we call this as dehydrating agent. Okay, this is the dehydrating agent. Then you will be getting ethene and water molecule is eliminated. So elimination of water molecule. Now coming to ethanol. What is ethanol? How do we write it as CH3, CH2OH? This when it is treated or warm or strongly heated, concentrated sulfuric acid at 443 Kelvin. Okay, so this delta marks tells that we are heating the mixture. Then you are getting C2H4 plus H2. And coming to the structure, you can also understand it as CH3, CH2 and OH. Okay, here in this case, remove this hydrogen and remove OH. So H and OH come out in the form of water molecule, and here unsaturation is like C. Now a saturated hydrocarbon is converted to unsaturated hydrocarbon by elimination of water molecule. Next again concentrated H2SO4. Right. So here a double bond is formed in between CH2, double bond CH2. This is what we call it as ethene. So this is an important reaction which we call it as dehydration of ethanol. Now, esterification. Alcohols react with carboxylic acids to form esters. This is called esterification. This esterification is done in the presence of certain dehydrating agent again, like concentrated sulfuric acid. What are these esters? Esters are sweet smelling compounds with functional group COO. We found these esters in flavoring agents as well as perfumes. So here I am going to explain you how ethanol reacts with ethanoic acid in the presence of concentrated sulfuric acid to give ethyl ethionate, which is an ester. Right? So esterification, here I am taking ethanol plus ethanoic acid. It gives you ester, ethyl ethionate. And water molecule is eliminated, and this is also done in the presence of concentrated sulfuric acid, and we have to slightly warm the mixture in a water bath, right? So once again I tell you, alcohols, they add or they react with carboxylic acids to form esters. Such type of chemical reactions are called esterifications. So here we go. Ethanol is COH. This is the formula of ethanol, and ethanol reacts with COOH. Okay, the OH as well as H are eliminated in the form of water molecule. You just add up the remaining water molecule. Like CH3COO. I have written this part, and now I'm including the other part as CH2CH3, right, plus H2. So this is called ethyl ethionate, an ester, wherein the functional group is COO. We call this as ethyl ethionate. You can also understand with the help of the structure. So if I elaborate the structure, this is the structure of ethanol. Ethanol reacts with ethanoic acid. Ethanoic acid is having an acid group C double bond O single bond OH. So that we need to explain by drawing the structure. C double bond O single bond OH. So here again, as I told you, remove this OH and remove this H. The remaining parts we have to combine. CH3 C double bond O single bond O. I have written this part, and the ethyl group is connected. Says that this is the ethyl group. H, 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 and H. The ethyl group is C2H5. So this is the structure of ethyl ethionate. So these are esters, which are the sweet smelling compounds. In the previous reaction, esterification, I told you that alcohols react with carboxylic acids to form sweet smelling compounds, namely esters. Now saponification is opposite to esterification. Like when esters are treated with dilute acids or with alkalis, they give back the acid and alcohol. So one such type of reaction is saponification. Here I am taking an example again. CH3COO C2H5. We call this as ethyl ethionate. This is treated with sodium hydroxide, which is an alkali NaOH. Then, what is happening here? Please everyone see. This is the acetate or ethionate ion CH3COO minus comes in contact with Na plus, such that a sodium salt is formed. So I am writing CH3COO Na. Remember, here there is a charge, minus charge and a positive charge. We call this as sodium ethionate. So this is an ester salt, sodium salt. Now, what are left here? C2H5 and OH. They two combine together to form alcohol. So C2H5OH alcohol. This is ethanol. Such type of saponification reactions are useful in manufacturing soaps and detergents. So saponification is quite opposite to esterification. Ethanol and ethanoic acid. Ethanol is an alcohol. Ethanoic acid is a carboxylic acid. Here I am going to explain you how sodium metal reacts with ethanol and ethanoic acid. In both the cases, hydrogen gas is evolved. You know about hydrogen gas. The hydrogen gas properties are liberation of hydrogen gas, or hydrogen gas is evolved as in a form of colorless, odorless, and it burns with a pop sound. In both the cases, hydrogen gas is involved, but the compounds that are formed when sodium comes in contact with ethanol and sodium comes in contact with ethanoic acid are different. Here we go. The first one, I am taking ethanol, CH3CH2OH. This is ethanol. Ethanol when it reacts with sodium. Just like an acid, here also a salt is formed and hydrogen gas is produced. So C2H5ONA. You can see here hydrogen is liberated out, and in the form of hydrogen gas, you can write it as H2, right? Or you can also write this reaction as CH3CH2OH plus sodium gives rise to C2H5ONA. We call this compound as sodium ethoxide plus hydrogen gas. So we need to balance this reaction and arranging 2, 2 and 2. This small compound is called as sodium ethoxide. Right. Then in the second case, when ethanoic acid is taken, there also hydrogen gas is produced, but sodium ethionate ester salt is produced. Like you know the formula of ethanoic acid, CH3COOH is the formula of ethanoic acid. This ethanoic acid, when it is treated with sodium nitrate, here also in this case also this hydrogen is removed. If you are supposed to write down that hydrogen, you can write it in half H2, that is hydrogen atom, or if you want to make it a dihydrogen, that is gaseous state, then you have to balance the reaction. Now here also CH3COONA. This is called sodium ETHAN OATE of the ester salt, sodium ethionate, and definitely hydrogen gas. So again I am balancing the reaction. Yes. So this is ethanol and this is ethanoic acid. In both the cases, in acid as well as alcohol, hydrogen gas is released, but the compounds are different. With ethanol, sodium ethoxide is produced, and with ethanoic acid, sodium ethionate is produced. I hope you understood all the chemical reactions, and I want everyone to practice all these chemical reactions.